My name is Tyrone Shu, and this is my Lab 3 magnetic field of a bar magnet. The presentation will go as follows. First, a brief introduction. Second, the setup of the experiment. Third, the results of the experiment. Fourth, a computational model supporting the experiment. And finally, a post-lab discussion. There are two main purposes of this lab. First is to determine the relationship between the magnetic field from a bar magnet and the distance to an observation point, specifically the exponent of which we set the distance, which we'll later find is negative 3.04. The second purpose is to determine the magnetic dipole of a bar magnet, which we'll find is 2.71 joules per Tesla. Some models and physical principle that we use throughout the lab, including the general magnetic field of a dipole, superposition property, which basically states that at a certain position, different magnetic fields from different sources can be additive or subtractive, and also the concept of linearization, which will be used to determine the value k and the value n. Now onto the actual experiment. The system of our experiment is the magnetometer on our smartphone and the surrounding, including the earth, which provides a magnetic field, and the bar magnet, which also provides a magnetic field. The initial conditions of our lab include the bar magnet being perpendicular to the earth's magnetic field. In order to accurately measure just the bar magnet's magnetic field, the magnetometer is marked off on the phone, and also the phone for specifically part 1 is located on the axis to the bar magnet. Within the actual experiment, we moved the phone along the ruler multiple times until 20, 70, 120, 170, and 220 microtesla was reached, and we repeated it 3 times and found average for them. Then we determined the distance to reach 100 microtesla, and then moved the phone up perpendicular to that in this with the same distance and recorded the magnetic field to that measurement, which we use as our 45-degree measurement. Now onto the results of our experiment. After we recorded all the data points, we applied the linearization principle, which we described earlier, by taking the natural log of each of the value and taking a nonlinear trend and turn it linear, and using this, we were able to determine that the exponent, which our distance is set to, is negative 3.04. Similarly, we were able to find the value of k and plug in into our equation and setting them equal to each other. We were able to determine that the magnetic dipole moment of the bar magnet was 2.781 joules per Tesla. This is the computational model that I use in order to model the experiment. I set 7 observation points, 2 which were on axis, 4 which were perpendicular, and 1 which was 45 degrees from the bar magnet, and determine the magnitude of the magnetic field of them using the general formula of the magnetic field, which was brought up in the introduction specifically for the 45-degree angle. Observation point. We were determined that the magnitude of the magnetic field was 2.66 times 10 to the negative 5. Now, this is slightly off our calculation value within the experiment, which was 5.48 times 10 to the negative 5. However, they are to the same magnitude, which means they are still relatively close with each other, though there are slightly different because the possible errors, which we'll brought up in the next slide. Now on the post-lab discussion to end the video. Some possible errors that could have made our computational and experimental value for the 45-degree angle measurement difference, including potentially not determining the right location of the magnometer in the smartphone, which could have set the difference distance differently, not moving the smartphone exactly perpendicular to Earth's magnetic field, thus having the Earth provide some sort of magnitude when we are just trying to determine the bar magnet. Also, the magnometer itself could have not been accurate. Now, which of these statements describe what we observed? What was observed was that when the magnometer is far away from the magnet, it measures a near zero magnetic field in the x direction, and also that the magnometer, as the magnetometer moves closer to the magnet, the measure and exponent of the magnetic field increases. So if we didn't count of the magnetic field produced by the Earth, each value would have been consistently off from the barbed magnets actual value by some sort of a portion of the Earth's magnetic field. And if we were stick it to identical magnets together and run the experiment again, we would have roughly the same exponent value, but measure magnetic field at similar observation point compared to the original experiment would basically be double. Thank you for watching.